Hi everybody, Dr. Pingle here with a quick tour of NASA's Visible Earth. Visible Earth is one of the sort of aggregate products that NASA puts out. NASA has a pretty extensive mission of monitoring the Earth from space. It has a ton of different instruments in space, so you can see a list of some of those sensors over here. And at times it's good to know a little bit about each one of these, and we'll get into more of that in our remote sensing unit later on. But what I wanted to focus on today was a really nice collection of data called the Blue Marble. So this is, again, a collection of data, composites, generally speaking, of satellite data. And I thought we'd just take a quick tour of some of these really quickly. So one of my favorites, so probably the first one that we ought to start with is the so-called Blue Marble. So the Blue Marble gets its name because it's sort of an aggregate of images taken from satellites. And this is sort of the classic image right here. So this is the Blue Marble. There are a lot of different orientations of this that you can look at. So this is what we would call an orthographic projection, and just a really beautiful image of the Earth, sort of showing it sort of as it would appear from space. So really nice pictures here. But you can do a lot more than just sort of look at these as static pictures. You can bring these in as GIS data layers. So I thought we'd look at a few of these. So we'll rewind a little bit here. And let's take a look at the topography layer just as an example. So this is a layer that's an aggregate of the Earth's surface. We can download these things as fairly large PNG files. So PNG is a portable network graphics file. Really good for showing images without losing any of the data, so it's what's called a lossless format. And this is giving the sizes, so 21,000 by 10,000 pixels or so, which is pretty big. So if we go to download this, actually I'm not going to try to load it in the browser. Let's back up here. What I want to do is right-click on this and then save the link as, and we're going to save that to the desktop. And you can see this coming in, so 17 megabytes for this image. And we can open this up and take a look at it. Just a really beautiful image of elevations around the world. So you can see Antarctica down here. You can see the Rocky Mountains. But what really stands out are the Himalayas and Tibetan Plateau, and the Andes Mountains. And you can see a lot of the really interesting features going on kind of along the Rift Valleys in Africa and through Turkey and parts of Iran. So really exceptional way to sort of look at this kind of all at once. Great image. If you want to bring in pieces of this, they've divided these up into sort of quadrants, and you can read about the imaging grid right here. So this is an example of what that looks like. So you've got columns A1, B1, C1, and D1, and then 2 on the bottom. So Northern Hemisphere is 1, Southern Hemisphere, generally speaking, is 2, and then tiled along some lines of longitude, so going over to 90 and then 180 and so on. So this way you don't have to download the whole thing all at once, although you can. It's just that these are fairly big images, and they've divided these up so that it's a little more user-friendly. So for instance, we could download all of the stuff in the Northern Hemisphere. So we're going to right-click and do Save As. I'm going to create a little folder here for elevation, and we'll save these. So we're going to grab A1, B1, C1, and D1. And these are coming in as GeoTIFFs. So we'll be talking about data formats a little bit later. But a GeoTIFF is one way to store raster formats or these grid-based formats. Let's come back to the elevation layer. And you can see these look pretty nice already. And we should be able to bring these straight in. We still have the gridded population data set from the last lecture. So let's drop these in here. Anytime you're going to bring an image in that sort of hasn't been processed before by ARC, it's often going to say that you haven't calculated pyramids. Pyramids are a way that we can take a look at images at different resolutions so that if we're zoomed way out, we don't have to load every single pixel. You can choose a pyramid resampling technique. Nearest neighbor is going to be the fastest, but it's often not going to look quite as good. So if I've got the time, I'll usually do at least bilinear interpolation. So that takes just a second to build. You can see that as it builds the pyramids, you're going to get these extra files that come along with the image in XML and in OVR. You don't have to worry about what those are at the moment, but it's good to know that they're coming in. So I'm going to bring all of these in as bilinear. Really doesn't take too long as the image isn't exceptionally large. Okay, so and we could bring in all of our images as well. You'll notice that we're getting some interesting things that are happening because each image is getting assigned its own value here. The ranges go from 0 to 178 on this image, for instance, but 0 to 183 on this image. One of the things that you can do is you can import symbology. So if you click on this one, what we can do is we can say we want to match our symbology to another layer. And in this case, I want to pick the one with the biggest range. So I'm going to match it to, looks like C1 is our biggest range. So now this is going to go from 0 to 253, just like C1. So we'll do that for all of these just real quick. Zoom out. Now, probably what we would want to do is recalculate those pyramids so that the seams would totally go away. As you can see, we've still got a bit of a seam going on in here. Another thing that we can do, if we really want this to look good, is we can merge all of these data sets together. Actually, what we want to do is mosaic them. Sorry, my mistake. So we're going to mosaic these all together. So mosaic raster. And we're just going to grab all of these. We're going to define an output location here. And we'll name it elevation.tiff. We won't worry about the spatial reference. That's going to be handled correctly. The number of bands is 1. We're only looking at a grayscale image. We could play around with the mosaic operators here first. In this case, we'll say first, and that'll be good enough. This will take just a second to calculate, so I'm going to pause the video here, and then we're going to load it back up again. So that mosaic operation has just been completed, so now we have this new layer called elevation. I can click on all of these and remove them. And then we can zoom to the whole layer. So you can see that at least the seams have gone away. Just like anything else, we can go through and we can change our symbology layers if we wanted to sort of look at these in a different way. And obviously you would want to pull in the southern hemisphere too when you're doing this for any assignment. So just for completeness sake, I've gone through and I've downloaded all of the images. You can see that these seams are still appearing. I just wanted to do another quick mosaic to new raster to sort of talk about a couple of the other issues that you might be interested in here. So I'm just adding in, again, all 8 of those in. It doesn't really matter that they're in order. I just like to do that so that I know I haven't forgotten any or haven't duplicated any. Now, I wanted to talk a little bit about this output location. So sometimes if you try to run this raster tool or any tool in ArcGIS and you don't have this folder created, you can have problems. So I can go and I can type in c.temp, and I actually know that I have that folder and that it exists. But if you've been following along at home and you don't have that temp folder and you type in something like my folder, you might get an error that says that there's a problem here. So it'll say my folder does not exist. If you try to run this, it's not going to work. And in fact, most tools in Arc will prevent you from running it at all. So you can browse, and I really encourage everyone to make sure that they are keeping track of their class data in some organized way. So for instance, we might call this one Notebook 2. We might have saved all of our elevation rasters in here, and we might call this the elevation mosaic folder, actually. One of ARC's peculiarities is that you sometimes in tools will specify the output location and the file name separately. So this is going to be, we'll just call it mosaic. Why don't we call it blue marble elevation mosaic. And I like to use underscores here as well. Now you can have a number of different extensions. I'm going to put down .tiff. It's kind of a standard. But you've got a number of different options. You could save these as PNGs or JPEGs or something else. The only other thing that it's important that you do is make sure that you have this number of bands set to 1. Again, we've really only got a grayscale. These aren't actual elevations. These are just sort of shading according to elevation right here. So a very important distinction. So we'll hit OK. And that's going to run that mosaic. Now keep in mind that this is a lot of data. If you try to mosaic all of these together, it's going to take a little bit of time. So don't be alarmed if it takes you a few minutes. I'm going to pause the video here until we're done. So that took about a minute on my machine, maybe less, maybe like 45 seconds. And then our mosaic has been added up here at the top. I can then get rid of all of these. And now what we have is a nice seamless version of the image that we were looking for. So this looks much better. The last stage that you might want to do is you might want to reproject this. So this is coming in as WGS 84, which is essentially like no projection. And so it's always good to sort of pick through here and find different coordinate systems that you might be interested in. A lot of times if you're working on images that are just going to go out, you can use the sphere-based stuff rather than the Earth isn't technically completely round, right? It's a little bit oblong, bulges out a little bit at the equator. But oftentimes you can use things like sphere-based coordinate systems. So, getting good practice at sort of finding different kinds of projections and using them, especially at the global scale, is good practice, and it's a thing that I'll often ask you to do as part of an assignment. So, one last note. And that is, when you're looking for this data, don't think that you have to browse everything from visibledata.nasa.gov. So this is where we started, and there are a number of good options under here for the blue marble. If you want to work with the night lights, this is fine too, and you've got some GeoTIFFs in here that you can download. But remember, good strategy is really just to kind of Google things. So in this case, georeferenced blue marble isn't a bad way to go. So think ahead and develop those good search strategies. If you go here, rather than having to stitch together a bunch of images, it's going to give you options to do things like download GeoTIFFs at various resolutions. So we could download this at 1440 by 720, which is still more or less high resolution. We would get a GeoTIFF or georeferenced GeoTIFF that we can then bring directly in. In this case, we're getting a warning that those coordinate systems don't match up, but there you have a nice easy way. Don't think that you have to go through all of these steps to sort of download tiles and mosaic them together. There are faster strategies out there. If you can search for blue marble GeoTIFFs, that'll be a much easier way to go. And then, of course, you can go ahead and reproject those any way you want. So there's a quick introduction to the blue marble and some ways that you can work with the data. Stay tuned for the next episode.